And we're back. Hi, everybody. I'm Alexander Pascal. It's nice to see you again. And joining me is Ian Shadden. Today we'll be talking about a game that he put together to show off hierarchical
game is loose.
instant static meshes. Yeah, it's called Canon Man.
Canon Man.
You know.
And actually, it's one of those things where it's easier just to show you guys. So, Clint is actually running the show today. So, Clint,
yes, thank you.
Switch over
thank
to
you, Clint.
the editor
Sully
real
is
quick.
out.
You will see probably a very familiar grid to many of you. And if I hit play, we see that we have a little dude. He's mouse controlled at this point in time. And he places certain devices. That when they explode, they take out blocks. So
perhaps you've seen a similar game with a different name that's already legally taken, so we can't use it.
Right. So as we were saying, Canon is the name of our lawyer. So
so we just decided to name it after him.
Yes.
For,
so there we go.
You know, safety's sake, we just put his name into things to make sure that we're nice and legally protected.
Yeah, that's right. Yeah, because his name totally protects us. Right.
That's how it works.
It doesn't work. That way.
But yeah, this is as you can see, based off of the top-down template. But
yep, got the mouse control. The guy, I'm using the space bar currently to plan stuff. So controls aren't done. Our guy's not going to die here, but it has all the basics that you need for some of this happening. The bombs detonate each other. They destroy the walls. Now the big thing here, and the reason this has to do with instant static mesh components, and hierarchical instant static mesh components, is that the metal blocks are all one draw call plus how many ever shader passes they have, and all the bricks are also one draw call plus whatever shader passes they have. So they are crazy efficient, but where the hierarchical instant static mesh components differ from just instant static mesh components is that we can remove instances from them. So it allows us to destroy them or shrink them down or move them around or transform them. So we're going to talk a little bit about that. I'm going to show you how I built it. First off, we do have a fixed grid here. It is generated in the construction script. We have a seed, so if we wanted to, we can see different things, but it also gives us completely fixed locations for everything. If we just find a seed, I think 122 is what we were using, and it was pretty good. And when we're doing grid generation, you can see that it leaves our player starts open. So this could be easily adapted for multiplayer games or whatever. So let's go ahead and let's look at our grid generator. So in our construction script, I'm going to be giving this, since we now have the actual ability to post these up, these projects, we'll be passing this one out shortly after the stream. I'll get Alexander here to either do it for me or show me how to do it.
Yep.
So we'll comment up these as we go, and we'll get these out to you. So if you happen to use a blutility for your construction script, we can actually spawn things in the editor. So it kind of became a habit for me when I'm building these kind of things to kind of fire off an event. I can't use spawn from within the construction script, but if I needed to spawn something in the editor or wanted to be able to do that very quickly, we could reparent this to a blutility and we could get those things done. And then in our event graph, let's go ahead and look at our generation for our grid. We are just doing very simple stuff here we need to make sure that we clear our stored collision. This is actually kind of important if we actually do have stuff spawned. The one thing missing here is actually destroying everything that ends up being stored in here.
Yeah, if you plan on it spawning more than once ever in its existence, then yeah, you definitely want to make sure you clear.
And we'd also probably want to do a for each loop here, and if we were doing a blutility for this, and we would do destroy. D-E-S-T-R-O-Y. There we go. Destroy actor. We have too many destroys now, jeez. And loop that in like so. That'll make sure that all of our, whoa, mouse just went all kinds of janky on me. This will make sure that we actually end up destroying all of our spawn collision, even if we've used them in a blutility and they've been spawned in to the editor. That way we don't end up with infinite collision every time we change the seed. Anyway, we're setting our random, our stream here, our random stream, and we're setting it seed. We're getting all actors of our class player start. we're just going to go ahead and store these so that we can have a range around which we do not want our disposable bricks to show up.
Mm-hmm.
And I'm doing some stuff by hand here, like I'm setting the mesh and the materials of our instant static mesh and our hierarchical static mesh components. As you can see, there's actually nothing set here. It's so that we could expose those as variables and we could swap them out for whatever we want.
Yeah, so I could totally understand if you've got a game that's set in stone theme-wise, you don't need to do this whole step. But if you have a game that you want a variable theme to, like hundreds of different block types and material types, then yeah, you would set it up like this, much more dynamic, but optional.
Optional. And then really, so in the one grid that we're generating, the metal grid, we're just doing a 2 for each loops.
Oh, so you made like a 2D
2
array?
for loops. Yeah, I'm not doing the fancy math for this one. Seriously, mouse, you're being kind of weird today. We are going to go ahead and we're setting our size, a relative location of our grid to be offset instead of being at 0, 0, 0. And if we put in whatever grid size we want, whatever mesh size, whatever mesh scale we want, that would offset based off of this chunk of math right here. And then we store that because we don't want to have to recalculate it when we offset our weak array, the bricks that we're going to be destroying. And with that, here are the 2 for loops where we are generating a grid based off of grid max x, grid max y. And this current setup actually requires an odd number, I believe, or is this an even number? It's even, which actually ends up making it odd. So it's 17 by 17.
Yeah, starts at 0.
Starts at 0. But for our metal grid, if we're just making a simple decision here, is it max x or max y or min x or min y? Then absolutely we are a metal brick. Otherwise, we're just simply asking, is it we're modding it by 2. So if the remainder is 0, meaning that we're even basically, then we put a metal block there and we go with it.
Yep.
After that, since we're going ahead and spawning everything at once, here are our stored player starts. Zoom in real quick on that. We're just saying I have 4 player starts here. You'd really want to do an array for this and check if you have a variable number of player starts, or we want to disable some of these. We need to put in some additional checks. But for what I needed for this demonstration, we went ahead and we just did the 4 that we have. We got their vector lengths, and we want to make sure that we are outside of a couple hundred units of those before we spawn a weak brick, the bricks that we can blow up. And then otherwise, we're just saying, hey, random chance to spawn one, is it over 25%? So we'll get about a 75% fill rate. And then when we do that, we add an instance, and then we also add a collision object, which, where's that function at? Where'd you go, function? Because I know I made you to do this. There's the add instance. There's the transfer. Oh, are we doing that after the fact? I think we're doing it after the fact. Yes, we are. We're actually generating collision on begin play. Because I didn't set this up to be a utility, so we just store all their transforms and we just spawn a whole bunch of them. Spawn collision shape takes in a few other values. They'll take in their mesh size and mesh scale, so the box will auto scale and auto position itself. And then we store that whenever we spawn them. Okay, so that's it for the grid. So when we come back and we look at it, we can see that, yep, min-max, we are solid along the way. This doesn't need any specialized collision. We just turn it on. The metal blocks just have it on. It works, it's fine. But our weak blocks, since we need to be able to detect which block was hit, and we're not going to get that information back, we'll get the component, but we won't get the transform of the one that we're actually hitting. We could do a bunch of math and figure it out. I mean, the blocks are of a set size. We could modify that by adding 100 or minusing 100 and figuring out its center point. But for simplicity's sake, it was actually simpler just to create our collision like this. What is Alex doing?
I was informed that this was left on. There we go.
Oh, were they hearing like?
It's apparently someone was pinging it. That's all. Go on. I'm
Oh,
sorry. I
okay.
didn't mean to interrupt.
Okay.
So,
Alex is
but
taking
now
control of the
now it
mouse.
doesn't matter. It's
Now
all,
it doesn't matter.
It's
So
all
apparently our
quiet.
volume was on. We apologize. So let's go ahead and we'll check out our collision really quick.
Mm-hmm.
Because our collision, all it does is set collision response channel of channel killable to block, and then we have a text renderer on it. I'm going to go ahead and turn on the text renderer because we get to talk about some fun ways that we organize data. So we're going to go ahead and turn that on, and the mouse is going to die on me slowly and surely. Or interference. I mean, it's a wireless mouse these days. And if I hit play, we can actually see all my bricks are showing their current indices, pardon?
Indice.
It's an index and indices. Yes?
Yes. Yeah. Indices. Yes.
All right. So actually, I'm going to drill up here so that we can actually see what's going on here. We killed like 42 and 43 and a 13 or something down there. We're going to drill up here through 54. And still need to go a little further. So 76, 71. Still need to go further, get through 87. And here we go. So, oh man, it's not updating those anymore. Well, that's frustrating because it should totally update those. Because it's really handy to see what's going on. Because this is no longer actually index 117. This is now index whatever the first one we destroyed was. I think it was like 13 or 15 or something like those. And they should be in the 40s, and these should be in the 70s, 60s, 80s. So
is it because it's on the collision instead of the mesh instance?
Well, that's the thing. I think I might have broken what we were passing to it when we were destroying it. So let's go back into our grid generator, and as per our stream normal, let's do a little debugging. So our weak collision has a kill event, and it has a mesh index removed. Oh. Remember that variable I probably destroyed? Yeah.
Oh, that's so funny. Just before the stream, he was looking through his blueprints and he saw a set, and he's like, "I don't think I actually need this set anymore.
Set
It
doing?
doesn't do anything. I don't think."
Yeah, well, it looks like it might have actually done something.
Yes, in your update down there.
Yep.
It was right there. You go.
Yeah. So, because it was pulling off of,
Mm-hmm.
it was actually pulling off of this.
Yeah.
So we do set index. There we go. That goes there. That goes there, and I believe we pull off of here. It's like, why am I setting this variable? This is silly.
Happens every day at Epic. Every developer here has to have that moment where you look at your stuff and you're like, I'm pretty sure I can take out some of this. Oh no, I couldn't.
Wait,
no.
What have I done? Who tweeted that today? It was actually somebody tweeted like that one time when you go in your code to fix a bug, and then you get down there and you're trying to figure out how it worked in the first place, like how it ever worked.
This is why comments in code, blueprint, everything are so important.
Yep. So we'll start drilling. Force of habit. I run away.
Yeah, they've already pointed out in chat that it doesn't hurt you at all, and yes, I already pointed that out to Ian. That
there, now you can see it.
That one is technically
97, 98, 113. So if we destroy 104, 99, and 93, these should change to those. So 104, 93, 99.
Nice.
Okay, so this is kind of weird. Well, let me rephrase. It's not weird. It's actually really efficient what's going on underneath the hood, but it's different than the way you would think it would work in blueprints. So in a blueprint array, when we were to like look at, let's say, stored collision here, if we were to come in and delete something out of the middle of the array at runtime, the array collapses upward. So if you were to delete index 3 goes away, and then 4 moves up, and then 5 moves up to 4, and so forth on the line, right? The way that a lot of arrays underneath the hood in Unreal Engine work in C++, and specifically how they work in hierarchical instant static mesh components, is actually like more like this. So you have your array, and you want to remove 6 from everything, right? So you remove 6, and what we do is we take 100. We don't actually remove 6. We just say, hey, 100, you're now in the 6th slot. So take whatever I've stored here, and we put it up there, and then we remove the bottom one from the array.
Mm-hmm.
So 100 ends up being copied and then destroyed off the bottom. This is a simplification. It's probably, it could be even more complex, or it could be more simple than what I'm saying. But just as a behavioral thing, this is the behavior you're going to see. So we have to kind of copy this. Because if you don't copy this, things end up really out of sync really quickly. Like, you'll be blowing up stuff in one corner, and for whatever reason, you can move to your left freely through the weak block, and you'll never destroy anything that way again.
Mm-hmm.
So this is the primary difference on what you can do with hierarchical instant static mesh components. Is we can remove an index, or an instance, or we can remove a group of them. So just so that you guys can see it, let's do a remove instances. They both do the same thing. This one just simply takes in
an array instead. Yeah.
And it does them in order. So if we were to, in the frame order of things, if we were to get 0, 1, 2, 3, 4, 5, it would remove 0, 1, 2, 3, 4, 5. If we got them in reverse order or whatever, it would remove them in reverse order. In fact, I had a version of this setup that would store up everything, and then on tick, on the next frame, it would destroy all the bricks. But for what we needed, it was actually really, really efficient and fast to do it this way. I mean, we're not seeing any frame hitching, and on my much lower end PC in the learning resources room, everything was actually working real good. So when a bomb hits, and the bombs are probably the most complicated portion of this, just lengthy. They send out a call to destroy the brick, the collision. And the collision says, okay, well, I'm going to call up to the grid. And the grid is going to, first of all, we're going to remove that instance. So that mesh goes away. And then we're going to get out of our stored collision. We're going to get that same index, because this green line that travels all the way down through here, right? This top green line is the same index all the way down. There's another green line down here. Yeah, we'll get to that one. This top green line is the index that we're destroying. So it gets that from the stored collision, and we're going to go ahead and we're going to say we're going to store this in another variable, and we're going to destroy it here in a minute. And as we move down, again, we're saying to the last index in our stored collision, so 100, 118, whatever, we're going to move it. We're going to tell its collision that is now another index. So we're going to move it up the line. So it's going to be like, okay, I'm no longer index 35, or I'm now index, whatever that was destroyed 6. Updating our text on our box so that we can actually see it operating in the world. And then we are mimicking this behavior that I showed you earlier, where we're taking the bottom of the list and putting it into the place where it was destroyed by simply setting the array element. So we're taking whatever index we're destroying, and we're setting the bottom one to that index. So whatever the last index is, we're setting in there, and then we're destroying the last index. So pretty chill, and then we destroyed the actor.
Yeah.
So it doesn't seem like there's a lot going on here, but this could be the foundation for a ton of different things. So my the dungeon room generator that I have.
Yeah.
What if I wanted to be able to drill through a wall?
Oh, I see.
Right?
Yeah.
This is probably way too complicated for that going on, but it's the foundation for setting up, how do we dirty this data? And then how do we repair that data by destroying meshes and re-adding meshes through their instant static mesh components? Or, well, rather their hierarchical instant static mesh components.
Yeah. And that would be interesting to see in, I think it got named strategy game.
It's turn-based strategy.
Yeah, turn-based strategy.
Sample something or
yeah,
another.
it's in the learn tab, and I highly recommend that one as well. But yeah,
I mean we've gone over that one before.
Oh,
and
yeah.
I have actually what was the last week's project? We actually showed an extended version of that one. So honestly, that's kind of really all that's going on. If you want to see like the bomb stuff,
Yeah, let's show off how exactly the bomb calls all of that functionality.
and we can actually simplify the bomb. We'll probably do that here live on the stream because the bomb is kind of ridiculous.
Well, you did basically copy paste lots of
Yeah,
chunks
it's
here
just like this is just easier
because it was just easier to copy and paste. Control C,
Right,
Control
it
V.
was.
Yeah.
So whenever a bomb is placed, so whenever its begin play is called, whenever it's played, it sets a timer for 3 seconds, sets its collision stuff so it can be killable, and then it forces its location into the center of a grid space.
Yeah, so it basically touches whatever the grid space is and says, "Move me to the origin."
Yeah,
of
I
that.
mean it does it by math.
Oh, okay, so it's
These are
Okay.
currently hard coded to like 2 and 100
because that's the actual literal size of the
literal size. But what you'd want to
blocks.
do is pass it from something.
Mm-hmm.
And be like, oh no, our grid scale, our mesh is actually this big, and our grid size, and we're scaling them up by X amount, and then we're dividing by that amount, rounding it, and then multiplying it back up by that amount. That way, we get it so that we can just completely cut it off. Everything's nice and easy, and then we set actor location. It does a teleport, so hopefully you don't get much motion blur on it. And then after 3 seconds, or the bomb is actually hit by something that destroys it, we spawn an explosion at the center. We follow a path down where we do a bunch of traces. There are 4 loops with breaks. So we just ask, have I hit something? If I haven't, then I will continue down towards the bomb's total power, which, I mean, we can jack up to completely ridiculous levels here. I think 10 is even way too large. But if we do that, no matter where we spawn, I mean, it'll just keep extending out and out and out, as one would expect.
Okay, so I have 2 questions from chat, specifically about the bomb itself. So I'm
Sure.
gonna ask those now instead of waiting to the Q&A since we're already covering this. What would happen if you dropped a bomb exactly between 2 grid spaces? And I feel like that is actually a physical impossibility.
It is, because we're rounding.
Yeah. So
So we're rounding based off of the mesh scale and the mesh size.
Mhm.
So we're dividing. So this, we'll just run through the math real quick.
yeah.
The cubes are 100 by 100 by 100. We're scaling them up by 2. So basically, we're taking their location in space and dividing them by 200, which should give us a really small integer, right? But, well, it's not going to give us an integer. It's going to give us a really small float. And then we're just saying round. So it's either going to go forward or back, and then we're going to multiply it back out. So basically, we're getting a grid index from that. So there's absolutely no way. I mean, I'm spamming the keyboard as I run here, and you can see that they're kind of jittery.
Well, because you're
There's
trying
motion blur, and there's like 5 different bombs. I'm spawning so many effects right now. You can tell that it really didn't like that I did that.
Yeah, you didn't put a cooldown timer on.
Nope,
on
there's
placement.
no cooldown. There's no.
and it doesn't
no
have like
limitation.
a counter. So there's a lot of things you might see in a certain complete game. Like you can only place a certain amount of bombs. They only go so far until you get upgrades, etc.
Yeah, there's
But those
no,
are more gameplay elements that weren't important to the actual
Right.
feature. But
So given the math, there's no way to drop it on the line at this scale.
yeah.
Now, if we had a weird mesh size,
Mm-hmm.
okay, we could end up with something maybe being really close, but I don't think it'd still drop on there because we're still doing math just to hit a grid index.
Okay.
What else we got on the bombs there?
Okay. So the bomb blast didn't appear to travel the entire hallway, and they were wondering if it was GPU culling or by design, and that one is by design.
That's right.
Yep.
Actually,
we can actually
if
show
just
you.
Showed, I just
yeah,
actually showed that.
This is.
So
I figured we'd probably end up covering it, but I just wanted to make sure that we explicitly pointed out how we're deciding that bomb blast.
Yep.
Because I think when you initially had it too, it knocked out multiple bricks, like anything that was in that
Yeah.
radius, and I
Yeah.
was like, "That's wrong, Ian."
yeah, actually, we can actually redo that.
Yeah,
if
you can.
we,
Yeah, if you want to just.
if we
turn
just
that
actually take out the break here,
on. Mm-hmm.
they'll go through everything. So they will continue to extend. They don't really. You're gonna lock my mouse in such a weird location. And it just doesn't care. It obliterated an entire length, and it'll go through metal as well.
Oh, oh, I see. Yeah, because
Yeah, 'cause it just doesn't care.
It's not checking. You
Yeah.
wrote in nothing to check against that.
Yep. Yep, it does. Well, that's part of what's being checked against with the break. So it gets to something that it cares about and it stops.
Mm-hmm.
And we have to, if we were to do it with players, we'd have to do another catch and be like, oh, if player, please do continue. But I still want to kill it. So reattach those. And now if we set our bomb power here to something more reasonable, like 1. Don't set it to 0. You can see that if I were to stand here, it just goes into these locations and does absolutely no damage. It can't hit anything.
Oh, it's only going 1 across, so
One
it'd have to be
across. So it'll
directly
hit-
adjacent.
Yep.
Yeah, and
Which
so,
is how you would start normally.
and so you would just make that like a dynamic number, and then if there's
Mhm.
power-ups in the world, you can make those.
Yeah, you would
add
pass
on
it from
to
your player, right? Your player would store its power-up state, and then it would say, hey, bomb, your power index is now whatever. Please blow up bigger. And it's like, okay. Now this is, again, we copied and pasted a lot of stuff here. But really all we need for this, and we can actually modify this to be much, much nicer, is we need an array of directions that we want to test against. So I'm going to go ahead and just create that real quick. We'll call this directions to explode. Make it all exciting. Vector, an array, and we'll compile. Well, we need 4 directions. We're going to need positive x, negative x, positive y, negative y.
Yep.
All right? Pretty chill,
Yep.
pretty simple.
And just immediately makes me think, hey, it'd be kind of neat to see like 3D, like where you have a z-axis also, and then you have to also jump up a block, and then you like, oh yeah.
Are you insane?
Oh yeah. Oh no, I've got ideas now. Oh yeah.
I don't know,
I hadn't even
man.
considered the z-axis until you were typing it out right there, and now I can't stop thinking about it.
I don't know. You sound like you're talking crazy talk. So
Maybe.
yeah, he's like, yeah, maybe, whatever. So we'll go ahead and duplicate one of these pathways again. And I'm gonna need that bit. I think that gets us. We'll find out real quick. So we have 4 directions to explode. So this should run 4 times. We're going to need to get, yes, we need our previous end. We need that to restart every time we run through the loop. Because this is outside of our start location. And bomb power, yes. And then previous index, yes. However, this bit right here, actually, what was there? We have a make vector. We actually need this now to be float times vector, I believe. Float vector, there it is. And then we need our bit here. A little bit of spaghetti here, make sure it's working. And then we add that location to there. I think that covers it, doesn't it? Because we don't need to multiply by negative like we have some of them below us. We don't need a break for this. We're resetting the previous end every time we enter the major loop. I think that works. Because that carries on. Yeah, all right. One way to find out, right?
All right, now we're doing this one live without any testing, so who knows?
That's how we normally roll. Testing. Okay, index 32 should go. Index 32 should go. 44, 31, 33. All gone. All right, so that appears to work. Now, what we need to do is increase our bomb power. Increase that to about 3. 3, okay. Compile. out of the way. Play. Now it should, for one, stop on metal blocks. And it destroyed that one down there. Great. And they kill each other probably just fine still. Yep. There we go.
Do the bombs set each other off?
Yes.
Oh, okay. So that's proper. Oh, cool.
Yep. There's currently no optimization in that, though. If fire is spawning, fire is spawning. So for each one of those, we're currently getting, what? 3 times 4 plus 1. So 13 explosions times 5 bombs. So whatever that ends up being for particle counts. It's really wasteful. But we could go ahead and handle that. But there is one other thing that I want to talk about. That I don't think I can handle it live on the stream. I'd like to be able to handle it live on the stream, but I wasn't having much luck with it on last week. So when we destroy what happens to index 100 when I destroy it, right? Like 117 becomes index 100. What that means, though, is that everything comes along with it. So I'm currently using per instance random in the materials, which is great for creating a making sure not all these bits look exactly the same. I mean, you can see it, like light parts in this corner comparatively to that corner, so everything looks kind of different. Without that, everything looks really samey. I took one of the materials in the starter content and I added that into it. So if we just zoom out and pull over here, we can see things that I'm per instance randoming, just adding a little bit of variation to all the UVs. Problem is that comes with it when we move. So if I destroy, where's one that looks really, actually we'll just destroy all 3 of these. And when I destroy them, keep an eye out on these 3 up here. They all changed. They're all slightly different now, but they're not slightly different. They're the same cubes.
Yeah, they just got swapped out, basically.
Yes.
So, I mean literally.
They were moved. I mean, another way to look at it is those were moved up there. So that's a bit of an issue using per instance random in this case. It would probably be better to use some kind of projection down on them, or I don't know, maybe that's a bug. I mean, I haven't even considered logging it as a bug. Like if you're going to move that data, perhaps not move that bit of data, but I'm not sure what would happen. It's probably not very efficient. Or maybe it's not considered. Maybe we shouldn't be using this in this fashion. But either way, just something to be aware of if you're going to try to do something like this.
Yeah, you can work around it. It's just that it's something to be aware of.
Yeah, if you're destroying your meshes and you start seeing different ones appear all over the place, then yeah, that is a bit of an issue. So, do we have any other questions?
Yeah, we have a few more if you'd like to hop on into
I would.
the Q&A. Cool. Okay, well, foliage is a bit different. Does HISMC support static lighting?
I believe so, yeah.
All right.
I mean, it's just like the instant static mesh components.
Yeah.
It's just, you got to remember, though, if you start popping these things, you're not, that's not, the data's not going anywhere.
Oh,
right?
so
Like
the baked in lighting is still going to
lighting.
sit there. It's not going to vanish at runtime.
In fact,
that's how baked lighting works. So
actually, you want to try a horrible test?
Let's try a horrible test live.
Yeah, let's.
This is what we're famous for, is just doing whatever and breaking
Because
stuff.
I have a feeling that this is not going to be pretty. So where's our? We'll do movable, just so we can see the shadows. I'm going to try to give us some deeper shadows there. Mainly trying to get stuff like this going on, right, where we can have a bit of an edge there. All right, there we go. So that way we can kind of have baked shadows onto stuff. So we'll take it back to static, and we'll build our lighting. As long as we get, just build.
Oh boy.
That's fine. It's only going to build lighting anyway.
Cool.
And we're probably on Swarm, so
Oh, well, we're on the Epic Swarm. I think we should be okay.
yeah. Whoa, it did not like that.
Map check found some issues.
Really? Oh, it might be because these are in Blueprint.
Oh.
Hold on, what does this say? Large actor receives pre-shadow and calls extreme performance unless B-cast dynamic shadow is set to false. Okay. Is that on our... Oh, jeez, I should have looked. Is that on our light or was that on the mesh? B-cast dynamic shadow is false. I think that's on our light. Oh, squint. Cast. There it is. Although I don't think that's going to affect the weird yellowness that we have going on. And no shadows. I could be wrong. Maybe these things don't actually cast. Maybe it's now the object.
Maybe it is only dynamic.
Okay, maybe not there. What about on one of you guys? Oh, there it is. Okay, let's turn that off and turn that off. I mean, our light wasn't... Oh, well, we have other lights in this... Oh, wrong button. We have other lights in the scene. I forgot, we have the dynamic skylight. No, it really seriously does not like static shadows. I was almost sure that these would work, but maybe not. I think that's something we're going to have to push to the forums, and I'll get some answers for you guys. Because I'm not entirely sure. So, we'll get back to you.
All right.
That seems like it should work, though. Anyway.
Doesn't seem like it should turn everything green.
No,
But
it really doesn't seem like it should turn everything green.
Yep.
Could be a problem with my scene or
The
anything
material or
with it,
something you
yeah.
set up. It could be a lot of different factors.
Yep.
But let's see here. What is the primary difference between ISMC and HISMC?
The ability to remove instances.
Okay.
I mean, and change them. I mean, we don't just have to remove them. We could update their transforms.
Okay.
I believe that is actually, that's the bomb. We don't need the bomb. Grid generator. Instead of deleting, I think we can just add instance, remove instance, get instance, transforms, update instance transform. So we can update our instance transform. And Alex just got up and turned down the lights. I'm not entirely sure.
Just fixing a minor lighting issue.
Alrighty. So we can actually update the transform. So another way that we could handle this. So I was talking about the material issue with the per instance random stuff, right? Instead of destroying the instances, we could shrink them down to 0 and hide them, like just drop them under the world kind of deal. And that would prevent any issues that you would have with changing the actual instances around. So there's that. Let's see. And what other questions you got there?
All right.
I mean, that's really it. It's instance static mesh components are fixed.
Yep.
You add them, you're done. You know, if you need to clear them, you can clear them. But you can't, that means you still have to rebuild everything in them if you just want to remove one.
All right. So, question about by hierarchical, does that mean the meshes are can be nested one in another? And I guess that's it. But no, it's.
I think it's just the way the data structure is arranged.
Yeah, it's just that it's structured in that way.
Yeah, it's the bit that actually allows for the removal.
Mm-hmm.
So.
All right. Are we in 4.11 or 4.12? We're in 4.12.5.
4.12.5.
4.12.5.
Yep.
So that's the one we're currently working out of. Stay tuned for 4.13 previews. They're on their way.
Ooh, yes.
And let's see here. How multiplayer ready is this project? It's not. This is built for single player.
It's totally ready. for you to implement it
yeah,
using Wes's videos
yeah, it's
on
actually
multiplayer.
I mean, at this point, it's actually not so complex of a project that it would be difficult for you to inject replication. So it's not
Well, okay,
multiplayer ready, but it
wait,
it
it says
wouldn't be.
multiplayer. So with that, I
Oh,
could also argue
you could do couch co-op.
couch co-op would be easy.
Yeah, couch co-op would be very easy. It's not pre-built for that, but yeah, it would
I mean,
be
you would
incredibly simple to
you
just
remove the camera from the
Mhm.
player, or rather, you get a new player and just have the camera float, and then everybody controls their own pawn.
Mhm. And in fact, there's actually tutorials for how to make a camera that dynamically zooms in and out based off of the distance of two players from each other, which
Ooh,
would look pretty slick, I
that
think.
would be pretty slick, actually.
But that's just me. But if you want it more like the classic game that this is based
how
off
would
of,
you-
it would be a
but how would
fixed camera.
How would you know when to run?
How would you know? Oh, well, you'd see them kind of going off somewhere and doing something.
Did you see that guy's split
So-
screen? The Voronoi? How do you pronounce that?
Is it the one that merges back into itself?
Yeah, it's like a
and-
splat. It's
Yeah,
a
that's
split,
always
and
cool.
that's doing this. and it's,
yeah, and then it
it's
just,
increasing the border width the further apart you are.
yeah, and
I
then
thought
as you
that-
get closer, it
I'm not
thins
sure
out
how
until
that
it
would really play
vanishes.
because you could go around each other, but oh man, it's really really slick.
It would be really cool to see. Yeah.
So
Let's see here. If the hierarchical, I'm just gonna be like hisms, hisms.
the hisms.
Yeah, if hisms give you more control, why would you ever use regular isms?
I would I would assume there's some amount of overhead to use them, and as you see, we're having some rather odd, like lighting issues. Actually, I wonder if it's just now because of the skylight. I mean, we can get rid of some of this. Skylight can go. Does that do anything for us, or we just end up with nothing? Well, that looks normal. That's a plus. But that's black. Okay. Well, let's do. Well, no, because they'd all be dark on the same. No, that might work. Let's just. Sorry, I'm thinking to myself about how to maybe show this off, and we'll reverse the side on where the darkness is, because you can see like there's nothing down there now. But if we hit build now, it just doesn't. I think there's just too much bounce lighting going on. Although weirdly, we're not casting onto the ground under here, which would be the other issue, of course, right? Like if this was casting a shadow down here and we destroy it, well. But it shouldn't. I mean, they're all exactly the same because we're using a directional light. Yeah, that actually that breaks it. So point light. That'll fix it, or break it horribly, whichever way you want to look at it. We'll make it static. Build it. And if there is anything going on, and this information stays. It does not. Okay, yeah. I have no idea what's going on with this. I'll have to ask. So, sorry. Anyway.
All right. Okay, so that was an attempt. We tried. Don't always succeed, but tried. Let's see. How nice do hism play with culling? Is there something happening behind the scenes, or is it the same as ismk? Stop laughing.
They're just sitting there.
I just got tired of saying the whole thing.
I mean, it is a long thing
Sorry,
to say.
hierarchical instant static mesh component or instant static mesh component. There,
So
fill it all in.
There's a lot going on with culling on these things. One of which you can do through the material. There is actually, they have their own culling setup, but it's still the same thing. Let's see, where is it? Let me bring this back over here.
Starting to do little gestures at Clint. It's like main screen turn on.
Oh, Clint's not
Gotta wake it up.
He's got to be paying attention. So actually, you can look up cull. So you can do start and end cull distances. And if I remember correctly, let's see. Each instance begins to fade out. This doesn't do anything by itself. Jeez, we got time. Let's set it up. This is always fun to set up. Actually, I guess we should ask to expand the question. Like, there's no functional difference between them, right? Like, because the way the question is laid out, is there anything different that these things do? And the answer is no. I mean, if that's the question you're asking, there's absolutely nothing different that they do between instant static mesh components and hierarchical instant static mesh components. However, if what you're asking is, can you do stuff with it? The answer is yes. So I'm going to punch in some numbers here for cull distances start and cull distance end. I think it's a low number than high number. It's like a range, right? So a band. At further than 750, it's completely cold. Closer than that, it's only partially cold. And we're going to do this, well, that worked. There they are.
Oh, wow.
Actually, I didn't know we had this whole fancy thing in place. I remember back when I tried this to start with on these things, you had to do it yourself. You got material inputs.
Oh, deselect it also, because I think the selection is causing like a color. Yeah, there you go.
Yeah, they do a nice little fade
Yeah.
in. That's actually really cool.
Yeah, that's a really nice dither effect.
Well then, I guess I don't have to go into the material. Wow, this was much quicker than it was going to be, because I was about to go into the material and set up a whole fade for that.
Wow.
I don't have to.
So much performance right there too. Like,
Yeah.
yeah, you have so much control.
I mean, because that looks like it's probably doing an alpha test dither in,
Mm-hmm.
so it's not even. It's like almost no extra cost.
Yeah, I
So-
mean, and geez.
Nice.
Yeah. Yeah, you could tweak those modifiers just a little bit until it's a really good range of them, and then, throw
Right,
this
I
on
mean,
mobile and it would run
For what
very
we're
well.
doing, whatever.
Yeah, well, it's
right?
unnecessary
It's
for
unnecessary
a PC
but
of this strength and all that.
yeah. I find it interesting. I wonder what the. Here's the thing, though. What is this really used for? Because if I just put in max, it kind of just works. Let's do a 750 and 1500, right? Is there anything? Does this something remain half faded? No, it fades in completely. I think those might actually be only used for the material if you want to use them in that fashion. Otherwise, it looks like really all that happens is the max one gets used.
Is there any way to disable the dithering and just have them pop in? This is a question from Motorsup. He was asking about dithering before, but I didn't even.
Volume modifier. This is one of those where I think if we modified the material, yes. But the way that it stands like this, no. Because if we go into material, we should, I think we get those, we get that data for it. Cull. Yeah, dynamic cull, distance cull fade.
Mm-hmm.
So we can change this. We'll take it to translucent. Which is terrible, shouldn't do this. Feed that into opacity. Apply. Wait for it to build. This completely ridiculous and completely overweight shader. Oh yeah, look at, ooh, that's terrible. And then if we go into back in grid generator, I have it set for 0 and 1500. Maybe if we set it for like 1250, it'll handle a little bit better. Well, no, it looks like when it's coming in, it just kind of makes it happen. But if we set, oh man, that is absolutely terrible to look at. Is there a way we can rotate this so that we're getting at least a layered view? No, actually it looks... Yeah, anymore, it looks like, unless there's a... let's look at culling down here. Now, it looks like they're still going to do that fade in. Huh. I think that might be another question we'll have to answer. I'm sure the answer is yes, you can do that, but you'll have to get down. There's probably a flag in C++ somewhere that allows it, but it's not currently exposed to us. Unless there's something in here. Let's see. Instance. Static mesh. We can set the cull distances, but there's nothing that's like fade in, fade out. So, I don't know. Feature request or bug. We can ask.
No, yeah.
Because I remember having to handle this by hand. And so I did my own kind of fade in through alpha test and a funny texture. So, but apparently now we just kind of handle it.
All right. Let's see here. I'm guessing that our instances of stuff cannot be smart actors doing things. They have to at max just be standing still. Okay. So yeah. So they're basically the question is like what all can they do, etc. But yeah, the actual hierarchical. I'm wordsing so, but anyway, the component itself isn't going to actually do anything. It just kind of stores all of the instance data, but that's about it. But you can make the blueprint itself that's carrying that component do whatever.
We can make the actor move.
But yeah, the component itself is dumb, but all the stuff that's holding it can be very smart and do things with it. So,
and also, okay. So we can. How do I say this? We can talk about levels of efficiency, right? But if you wanted to update the transforms on these every frame, you could do that. I mean, this is going to be probably slightly gross, but let's get a tick. And we need you. And we need to... well, okay, we're going to need to know how large this is. Thankfully, we have a way to do that.
Mesh size and scale?
No. Pardon, the array size.
Oh, the array. Right.
But we know how big it is because we are duplicating it with stored collision. We'll get last index. We'll do a for loop. Last index. First index. And we'll see how badly this barfs. And then we do transform. Update instance transform. I guess we could, let's do, I think I saw a git. Wasn't there? Oh, that was interesting. Yeah, look at that. Interesting. That bit wasn't showing. That was kind of odd. So we're going to go ahead and get our instance transform, and then we're going to update it rather hilariously with a random number.
So as they come in, they're just going to be kind of at jaunty angles?
No, we're going to update them every frame.
Oh, okay.
Yeah.
We can do that, I guess. Technically, that's acceptable.
Technically, it's not acceptable.
No. It's only acceptable technically. I would never recommend it, but it is technically a thing you can do.
This is a test. Rand in range. Random float in range. Let's say we'll make it really obvious. -50 to 50. Plus that. Make vector. And we'll reconnect that to Z. So these things will be very jaunty. And we'll do that.
Cool.
And I believe we're getting these in local, returning them in local. Mark render state dirty. If true, the change should be visible immediately.
Oh, then yeah. You need to do that.
We will do this.
Since we're doing this on tick, we're going to need that, I think.
So I'm going to save.
For those of you just joining us, Ian has decided to do something on tick, which isn't really necessary to do on tick.
No, what do we... Oh, oops. Did anybody catch it? Ian.
One of your targets is off. Oh, the index.
He didn't plug in his index. So 0 is down there flipping out.
Everybody else is fine though.
Everybody else is fine.
Yeah. Well.
Okay.
Oh, did you?
Hold on.
Did you set their location and then do it off of?
Let's do. Sorry, I'm changing the material off screen.
Oh, setting the material back to normal in case
Yeah.
in case you just turn them invisible, which you might have.
Yeah.
Unless
50
they were
really isn't that far though. Plus or minus 50.
Well, on
local.
on tick.
Oh, but we're doing it on tick, and they might be going to the moon really quickly.
Yeah. So, considering how many frames this thing can run at.
Here, we'll do this. Clamp.
Oh, there you go.
I believe they're all being spawned at 0Z. No, they're being spawned above that. So they should be spawned at 100.
Oh, you're setting their location, not their rotation. I see.
Yes. 50 to, or 150 to 50. It should make it visible. Oh, maybe I should plug it in. There we go. All right, let's try that. Well, did not like that. Maybe it's that thing.
Nope.
Nope. It is not liking doing this on tick. So
XY at 0. Setting your location to XY 0. You need to just no. It's your X and Y for your brake vector need to be attached
thank you
back.
guys. They're all now being jaunty in the corner.
You forgot the other cohorts.
All right.
All stacked on top of 0.
Ah!
There we go. That
They're scaled down because I didn't do the scaling
the
thing.
scaling, yeah, didn't go back in, so it just auto went to default 1 scale.
I have to see this. This is
What is our FPS?
just around 60. It's at 54.
Amazing.
It's probably. It kind of is.
That's pretty impressive.
Although I'm pretty sure there's a programmer somewhere in this building who was going, "Oh God, why did you do that?"
There.
We dropped about 4 FPS, 3 FPS doing that.
Yes, and not bad.
Not bad. I mean, could be way, way, way worse.
Ship it.
It's gold. And we could do a make.
Yeah, instead of the weird thing you got going on there.
Yeah. Then we'll just plug in our rotation
And scale.
scale.
You can get rid of that other convert to transform node that's just floating out there.
Yep. And arrange your spaghetti. Nope. I refuse.
So we're not going to be putting this nonsense in the project we actually
No,
put
this
out.
project.
But you could recreate it if you really want some nonsense. But just to show that, yes, this stuff you can actually interact with and do stuff with in the strangest way humanly possible.
Yeah, and it probably looks a little smeary, but
Wait,
that's due to.
Can you blow up things?
yeah.
I mean,
Oh, yeah.
I mean, that's.
Oh yeah, that'll still work. I mean, the collision handles all that. We're not moving them.
Oh yes, those boxes are still there. That collision. So you can make everything totally lose its mind.
Yep.
Oh yeah. Oh, and you can see that it's actually still fading in too as you were moving up to it.
Yeah, I know, right?
So we're saving those cycles.
We're saving all. We're getting all those cycles saved. So all right, well, that's completely
Okay,
ridiculous.
cool.
But fun.
So those are all of the questions that I've received about this project and this particular thing today. All right, so yeah, if there's anything else that you'd like to show off in the project.
No,
No?
actually, we're right on time. It looks like.
Oh, hey, that's really cool.
So
Yeah, thanks everyone for sticking with it and asking your questions and seeing all this nonsense. What are you doing?
I'm planting bombs.
He's still playing games.
Oh, okay.
At this point,
Oh,
he's
that's
just
right. We're
having
not on
fun.
the screen. Sorry, right down there.
Yeah. So too late. It's too late.
Too late. You
So-
missed it.
So thank
Gotta
you
be
all
paying attention, Clint.
for joining us. We'll see you all on Thursday.
What's going on?
We got Thursday. We're doing the announcements for the winners of the July Game Jam, and we'll probably be doing something really cool with our friends over at the team that made Dangerous Golf. So we'll be showing some of that stuff. It's a fun game. It really is crazy fun. So yeah, but thank you so much, Ian, for coming on and showing us all this and having a wacky adventure with us as usual.
Yep, and actually next Tuesday it'll be Lauren and Richard again.
Mm-hmm.
They're going to be on with Tanks versus Zombies part whatever. I'm not even
I think
sure
we're
what
on
the 6?
Yeah.
Um,
But and so yeah, that should be a pretty good one.
Yep.
C++ tutorial. So
Yeah.
jump in on that one if you're into C++. But yeah,
and
we'll
then we're back in a couple of weeks after, sometime down the line.
yeah sometime down the line we'll be back in doing even more. So
Yep.
yep. Thank you all for coming out. We'll see you later.
Bye.
See ya. Bye.
Take it easy.